Good evening, dear students. In the previous lecture, we have seen the Z transform, how to calculate the Z transform. The formula is x of z is equal to summation n equal to minus infinity to infinity x of n z power minus n. In this lecture, we are going to see about the inverse Z transform. To find the inverse Z transform, we have four different methods. Actually, we have so many methods. So, in this video, we are going to see four methods. The first one is long division method, otherwise it is called as power series expansion method, and the second one is partial fraction method, third one is residue method, fourth one is convolution method. Now, first we see the long division method. The problem we have taken is find the inverse Z transform of x of z is equal to z plus 0.2 divided by z plus 0.5 into z power z minus 1. So, here we have to do the inverse Z transform for two different ROC values. ROC represents region of convergence. So, region of convergence, the first case it is mod z greater than 1, that means it is for the causal sequence, and the second case is mod z less than 1, it means it is for the same x of z we have to calculate if it is an anti-causal sequence. Causal sequence means the sequence is having values only in the right hand side, in the positive side, and if it is an anti-causal sequence, it is having values only in the left hand side, that means the negative side. Okay. So, for both cases we are going to find the inverse Z transform, right. So, first we take the first one, which is the mod z greater than 1. So, mod z greater than 1, it is for causal sequence. So, for causal sequence, the power of z has to be taken in terms of decreasing power of z, right. So, first we multiply and take the x of z value as a single term. So, x of z is equal to z plus 0.2 divided by, multiply both the factors, we will get z square plus 0.5 z minus 0.5. This can be written as z plus 0.2 divided by z square plus z square minus 0.5 z minus 0.5. Okay, this is x of z, and here you see the power of z is z power 1, here it is z power 0. So, it is the decreasing order of z. The same way in the denominator z square, the power of here it is z power 1 and here z power 0, that means the z is in the decreasing order, right. So, as such we can take this x of z to calculate the long division method. 0.5. So, as you have studied in the school days, in the same way we are going to calculate it here also. Okay. So, in the long division method, you put the dividend here and divisor in the outside of the division. Okay. Here the rule is first term of the dividend divided by the first term of the divisor. Okay. So, the first term here is z and here the first term is z square. So, z by z square, which is equal to z power minus 1, which is taken to be the quotient. So, z power minus 1 is the quotient. So, we have to multiply this z power minus 1 with all these three terms. We will get z power minus 1 into z square, which will be z. Okay, z power 2, z power minus 1. If the base is same, power has to be added. By using that same formula, we can write this z square into z power minus 1 can be written as z, and you multiply 0.7 z power minus 2 with z square. So, 0.7 z power minus 2 into z square can be z square z power minus 2, it will become z power 0. So, we will get the 0.7 into 0.7 z power minus 2 into z square, that will become z power minus 1 into minus 0.5 z, that become minus 0.5, and z power minus 1 into minus 0.5, that will be minus 0.5 z power minus 1. By subtraction, we have to change the sign of the second term. So z will get cancelled, this term will be plus, and 0.5 plus 0.2, which is 0.7, and this is plus 0.5 z inverse. Okay, then the same process has to be repeated. The first term here 0.7 divided by z square. So 0.7 divided by z square will become 0.7 z power minus 2. Then the second part of the quotient will be 0.7 z power minus 2. Okay, so multiply this 0.7 z power minus 2 with all these three terms. So 0.7 z square into 0.7 z power minus 2, which will be 0.7, minus 0.5 z plus into plus 0.7 z power minus 2 becomes minus 0.35 z power minus 1, and again 0.7 z power minus 2 into minus 0.5, which will be minus 0.35 z power minus 2. We have to subtract by means of changing the sign. So 0.7 will get cancelled, then by adding we will get 0.85 z power minus 1, again by subtracting by changing the sign, it will be 0.35 z power minus 2, and the same process 0.85 z power minus 1 divided by z square, we will get 0.85 z power minus 3, that will be the third part of the quotient, right. Then the same process, by using the same process you will get this equation. When you subtract it, you will get this term. Here our aim is x of z can be written as, you can write the quotient. Actually this division is prolonging up to the infinite, so we are limiting here, and we can write this as x of z is equal to z power minus 1 plus 0.7 z power minus 2 plus 0.85 z power minus 3 plus etc. It will go up to the infinite. Okay. Now we know the formula of z transform as x of z is equal to summation n equal to 0 to infinity. This is for the causal sequence. If it is an infinite sequence, that non-causal sequence, you can take from minus infinity to plus infinity. Since it is a causal sequence, we take the formula is from 0 to infinity x of n z power minus n, which can be expanded as x of 0 z power 0 plus x of 1 z power minus 1 plus x of 2 z power minus 2, etc. When you compare these two equations, here there is no z power 0, so x of 0 coefficient is equal to 0. That means here x of 0 equal to 0, and if you compare the coefficient of z power minus 1 here with this equation, so x of 1 equal to 1, then the z power minus 2 value is 0.7, that is the coefficient as x of 2 equal to 0.7, and x of 3 is equal to 0.85. Okay, this is the value in time domain. X of z is in terms of frequency domain, and if you change it, if you compare the coefficient and write the values of x of 0, x of 1, x of 2, etc., that will be the time domain sequences. We have to finally write the equation as, the final equation can be written as x of n is equal to, since the power of z power 0, the coefficient is 0, we have to take from that, okay, 0, 0.7, 1, 0.85, etc. If you see this sequence, this here you can put the arrow mark which represents the value at n is equal to 0. Okay. So if you see this equation, after n equal to 0, you will get the value for n equal to 1, 2, etc. So this sequence is a causal sequence. Okay. That means it is having values only in the right hand side. Okay. The second part is, we can take it for the anti-causal sequence. The same x of z can be used for different ROC.